Okay, this is going to be a crash lesson on what happened in class on Friday, March the 28th. We did notes in class, but a lot of people were absent, so let me just put a condensed version of the notes up, and that way you can keep up if you were out. Anyway, the objective for today is to discern what shapes are formed by cross-secting solids with planes. Now, I said I'm not going to go into this in as great of detail as we did in class. I will just simply relieve it to you. Watch the video. If you are unable to follow what has happened or need further explanation, then it is on you to come in for tutorials and get that explanation. Okay. All right, now the basics of cross sections is the idea of our solids can be chopped into pieces, and then we become concerned with what the shapes of these pieces look like. Okay, so cross sections deal with taking a solid, cutting it into two pieces, and examining the shape of the surface that was created by the cut. Okay, so if we take, and my little cheesy graphic on the screen there is a little sword. If we took a sword and we chopped our solid into two pieces, okay, it's kind of like taking a knife, cutting an apple, and then opening up the apple and looking at the meaty part of the fruit that is now exposed. That is a cross section. Okay, so we're going to start off there, as you can see, with a cylinder. Now, there's a lot of different ways to cross-sect a cylinder. The first one that we have right across the middle of the screen is the idea of taking some type of a cross-section and cutting straight across through the lateral face of the cylinder, perpendicular to parallel to the bases. And if you did that, then obviously you would end up with two smaller cylinders. And when you open up that new surface that is now exposed because it's been cut open and look at it, you will see that that surface is circular. So one of the possible cross sections of a cylinder is a circle. On the other hand, we might cross-sect the cylinder so that the cut is not parallel to the bases. Okay, so it goes through the lateral faces kind of at an angle. Now, as strange as it might seem to some people, the cross-section, when you cut through at an angle on a cylinder, is actually what we call an ellipse. Okay, so if you're unfamiliar with the term ellipse and you've been calling it an oval all these years, probably time to make that change. It is an ellipse. And the reason it is an ellipse instead of a circle is because at an angle, it took a longer distance of travel from, if you look at the sword, up near the hilt, the base of the sword where the handle is, toward the tip. Okay, it took a longer length of cut to get through because of that angle. So you end up with your circle being stretched, and that's what makes it an ellipse. Now, that's not the only possibility. In fact, there's a lot of different possibilities. Excuse me just a moment. Wait for this announcement to finish. Okay. If we were to cross-sect the cylinder not through the lateral faces, let's say this time we come down from base to base. As you can see, you cut the cylinder open it up, take a look at it, and your cross-section would be a rectangle. Now, the reason we're looking at stuff like this is because this has actually become one of the favorite test-type questions we've been seeing lately on solids. They've been kind of preoccupied with this idea of cross sections, and we've seen questions that might say things like this: which of the following could not be the shape of a cross section of a cylinder? They would put circle, and they would put ellipse, and they would put rectangle like we just saw, but maybe they'd also put something like parallelogram or something like that, and we would have to be able to think our way through and figure out which of those shapes could not be the result of a cross section. Okay. We did the same thing with a cone. We did it a step at a time in class. I'll just kind of give you the gist of it now in this recording. Several different ways to cross-sect a cone. As you see on the left side there, we could go straight through the lateral face parallel to the base. We could go through the lateral face at an angle. We could go through the lateral face such that the end of the cut actually goes through the base, That's the third one from the left. And then, of course, we could cut it from the vertex down through the base. And as you can see, the cross sections there from the left, straight across parallel to the base would be a circle, and an angle would give us an ellipse, just like it did with the cylinder. Over at the very right, on the vertex through the base, that would be a triangular cross section. And there on that, next to the 1 second from the right, okay, we would end up with a shape that you should be familiar with. If you're not, you need to learn this term. It is a parabola, or some people will call this cross section a portion of an ellipse. As you can see, one side of the ellipse, or whatever you want to call it, is flat, and that is because of the flat base. The cone did not continue through the end of that cross section, so we end up with a side that is actually a line segment. Okay, and again, they like to ask questions like this: which of the following would not be a possible cross section for a cone? Circle, ellipse, parabola, triangle, rectangle. Okay, it'd be up to you to decide which one is not possible. We also did the same thing with a cube, and this one's going to be harder for me to explain over a recording, so I'll leave it to you to pause the video and look at this and see if it makes sense to you or not. If you need further explanation, please come into class during tutorial times, and we'll talk about it a little bit more. Okay, there was not an assignment that went along with this. The only thing I asked the students to do is I provided these two web addresses. Now, these are both applets that show animation of different shapes being cross-sected so that you can see some of the shapes done by the cross sections. And I'm going to show you the first web address here momentarily. Okay, but what I asked is for the students to find some time before the next test, which is going to be likely the ending part of next week. Take about 10 minutes per website and play around with the applets that are on these websites. Now let me show you the first web address there, the www.showdoor. Okay, this is what that web address does, and you can see this is the main screen that pops up from that address, and what we're looking at on the left side is a double cone. Now in this box where the double cone is, you can click, or if you have a tap enabled device, you can basically grab this cone, double cone, and you can move it around and look at it from different perspectives. Now clearly we haven't done anything like double cones or anything like that. Those will be more important in stuff like Algebra 2 or and definitely into pre-calculus. But look over here on the left side, okay, there are some radio buttons right here that say double cone, cone, cylinder, pyramid, and prism. And we can change the type of shape that we are looking at by selecting the different radio buttons. Okay, so again, when you have these different shapes up, these are touch or tap enabled. Okay, so you can move these guys around and look at them from different perspectives. Now, what you are looking at over in the grid on the right side is basically a graph of the cross section. Okay, so as you move through different figures, okay, the shape is changing according to what the red cross section is actually showing you. Okay, now what I want you to do is I want you to play with the slider bars that are right here in this area. Okay, moving these slider bars around will move the positioning and the angle and perspective of the cross section. And as you can see, as you move the cross section around, the shape of the cross section changes. Okay, and moving different axes will do different things to the graph. Okay, but what I really like to do on this particular website is here on the right side. You see where these have animate buttons on there. If you click the animate buttons, basically what we have done is we've put the website into motion on its own, and it will move through those different variables, and we can see how the cross section changes simply by watching the site. And we see we got a parabola going on there, or a portion of an ellipse, and it looks like it's trying to become a triangle, and so on. Now, one of the things you can do is above those slider bars, it says click to show identification of cross section. If you click on that guy, it'll actually tell you what the shape is. Currently, we're looking at an elliptical cross section. Okay. And as you do this, again, spend a little bit of time looking at the website, observe this, see what it does, change some shapes. Let's look and see what a cylinder is doing while it's doing the same thing. And again, while it's going through these, this area is still tap enabled. We can still manipulate this cylinder and look at what's going on with the different cross sections. Okay, and also you've got pyramids and prisms. Okay, let me turn this pyramid over, take a look at its base. See, right now we're looking at a pentagonal pyramid. He has a 5-sided base. You can control the number of bases that are on your pyramid and your prism. The bottom slider has number of lateral faces, so you can move it there, diminished it down to a rectangular pyramid. You can make it triangular, okay, and so on. Okay, but again, allow the applet to run, observe the cross section, see what this thing is doing. Okay, prisms, again, it always starts with a pentagon, and there's that cube. So if you're having trouble kind of understanding what the cube was showing you on the lesson, okay, here is what all the possible cross sections of a cube. And as you can see from watching the graph over there on the right, we range anywhere from a triangle all the way up to a hexagon, depending on how the cross-secting plane is interacting with the solid. Okay, so that was the assignment, to basically spend about 10 minutes on each of these websites. That would be 10 minutes each, 20 minutes total, and observe these cross sections. Okay, there is not really any way to get around this. If a problem like this shows up, you are going to have to understand what the cross sections are doing, how they look, and so on. And it's probably not something you're going to be able to just figure out on the spot. So definitely do this assignment. Spend some time on this website and the other website until you kind of get a good feel for it. Anyway, that's all of the information. Drop by if you are having more difficulty than just that.